Hello viewers, welcome to my channel Science to Technology. In today's show, Rocket Monday, we're gonna talk about flight on Mars. So let's dive right into it. Now, first thing we have to understand, we are talking about Ingenuity here. Now, this puppy is a solar-powered dual-rotor helicopter. Now, if you are familiar with something known as action equals reaction, you know for a fact that you can't just have one rotor, because if it's spinning clockwise, you will end up spinning counterclockwise. And that's why every helicopter that has single rotor generally has a tail rotor to compensate for that. Now, here NASA has some serious size limitations. So they are like, okay, this puppy has to fit below the rover, so we have to be a bit more practical. So they started two counter-rotating propeller design. Now this puppy does work. Now this was whole idea. The whole project was not a main mission project, not mission critical, aka. So this puppy was what we call proof of concept demonstration. Basically, show us that we can do that. Like basically, if NASA gets this done, and then NASA can go to Congress and be like, okay, now give us more budget for more flight based system, because this is a proof of concept that we have successfully done. And it was what we classify as high risk, high reward. So probability of failure was too goddamn high. So basically, this probability of failure on this sort of puppy is so high that NASA will never fund this sort of thing for main mission. They're like, okay, second mission, let's say we are going there, can you carry it along? Awesome. They're like, okay, you want to do this whole mission, multi-million-dollar mission, and you just have everything is like high risk. They will say nope. So be mindful. That's why there you will always have, like, one primary solid known stuff, then you will have something attached to it. For in this case, that was the helicopter. Now what does it have in terms of payload? Basically, we don't send a rover to Mars, we send instrument that is packed inside a rover. For example, spectroscopy, instrument that can drill onto the soil, drill onto some rocks, and study the material out there. So that's the mission. The rover is just a chassis for it. So what does this puppy do? Well, that's the limitation, because it's, again, as light as possible is supposed to be. This only has like basic sensors and camera. It does not have something fancy. Basically, your modern mobile phone has more sensors than this puppy. So what are the problems if you want to do basically actually fly on Mars? One of the primary thing is that it has very low atmospheric pressure. Now to visualize that properly, think of it this way. Let's say you are at sea level on ocean surface. You are talking about 15 psi. How much is it on Mars? Well, go 0.095. So basically, if you round this puppy up, it's like 0.01 psi. So it's almost plain vacuum. Now this itself is a problem for anything that has to spin and generate lift, or any wing that has to generate lift, but it's something manageable. But it does come with a significant cost of overheating. And I'm like, why the heck it's overheating? Because at pressures that low, everything is acting as an insulator. It's almost vacuum, so it's perfect insulator. Consequence of that is these motors, like the most efficient power to weight ratio and energy efficiency wise, is magnet based motor, aka BLDC motor. You can have some other designs, but generally you have to rely on magnets to have size and other stuff. Consequence of that is magnet do not like very high temperature. Like if you keep heating them up, after a point, like again depending on design, even with neodymium, they could have like, hey, you go above 80 degrees Celsius, I'm out, like permanently demagnetized. So these motors, even if you have a giant ass battery that can power this puppy for hours, you may not want to run it that way, because temperature will rise up again. Even with like a very efficient motor, you are still talking about around 2 to 10% waste heat that will trap, because again there is not enough atmosphere to dump that heat efficiently. So that will keep trapping, and by NASA's estimate, it was like around 1 degree Celsius per second. So let that sink in. Like this puppy will heat up without any limit. So if you had a battery system that can run these motors for, let's say, 5 minutes or 10 minutes, you can be damn sure that would be the last flight you're gonna take, because magnet will be demagnetized at the end of it. So these two things are very significant. So like serious limitation because of these things. And then we come to how the heck you're gonna provide power to this. So generally solar panel was chosen. Now this does work, but does come with a consequence that in Earth we have 1000 watt per meter square. On Mars you have like 590. That is very less. And again, what does that translate to? That translates to either you have to put bigger solar panel or small solar panel and wait whole day, almost like it's like almost wait for like 2-3 days to charge up, and then fly on the 4th day. So that these are some serious problems. Now it is successful. We know like it was a high risk thing, but they have successfully achieved it, so it is a success. So the first vertical takeoff, stationary hover and landing, basically go up, hover there, come down reliably, accurately, that was done. It was done on 19 April 2021 at 7:34 universal time coordinate. Now this puppy did work, and this is one of the few times where I actually watched the live stream live. So, and I was actually surprised because like this was kind of humanizing mission, because the people working there, they knew for a fact that this is a very high risk system, and the main person in charge of this, they already wrote down a letter what if it fails. And when it was like completely confirmed that everything was successful, she tore the paper apart. That was kind of humanizing moment. I like that. It's like, you know, there are people at the end of the day, there are people working on it. So, and again, if it fails, people are like, I failed. Like for them it will be like, dude, your years of work, poof. So fundamentally speaking, that was a kind of very nice live stream scene. And they achieved 3 meters of height, and the flight time was 39 seconds almost. Now be mindful, even if you can put a giant as battery into this, or like a lot of power, you may not want to run it that long. Now that was like that was the first. Then they had multiple. At this point in time, they are at 6th number, and on 7 May they achieved another aspect, that is on 1926 universal time coordinate, around 10 meter of height was achieved. That is almost maximum ceiling. It's not like if they keep throttling it up, it won't go up, but 10 meter was like the mission planned window. So it's like 3 meter was just testing, 10 meter is like, okay, this is the optimum height. Like most the camera will still work at that height while giving enough resolution. You do not want to be too far off where, like, you know, ground no longer provides enough resolution. You want to be close enough but not too close. So 10 meter was chosen for that, and it flew at that point in time for 108 seconds. Now this puppy on paper has a battery life of around 2 minutes, so they never pushed it to like almost 2 minutes. So maximum I have seen is like 144 seconds, but again, it's like, do not expect too much, because again, even if your battery power has a, you know, enough margin, you may overheat the motor. So it is a successful stuff. It did work. Everything is fine and dandy. They of course still have to work out some software glitch, but that's acceptable. Now what is the practicality of this? Like, okay, we had a mission, we had a technology demonstration, it worked. Now what? Now this itself, you have to understand, flat out, it's not the main mission. It's like, heck, at this point in time they're like, okay, what should we do with this? It's like, yeah, we wanted to test something out, we tested it, but the rovers can keep working for years. At this point in time, we have experience, like, you know, rovers that have been working for 10 years or 12 years. So it's like, this puppy will not you know, tag along for that long. However, it does have the benefit of super high speed. Now rovers are idiotically slow, not because they do not have the energy to move fast. It's simply done to as a protection. Basically, if rover tilts over or falls over, there is no way to fix that. It's done, the mission is over. So they are very cautious, like idiotically cautious. Now you may be like, don't we scout the area where the rovers are gonna land and how it's gonna take the path? Well, there are two limitations of that. Primary limitation is satellites are far away, so they have what we call angular resolution, which is not very fine. So basically, how much of area it can see with any known resolution is very low. For example, let's just go with 1 pixel would represent 1 meter square. So you're not gonna see much. Of course, a mountain range, big land masses, awesome. You can make a large surface area map for that. But is it enough for, like, you know, your rover? Heck, your rover could fit inside 1 pixel of a sensor. So you could literally, okay, there is this one dark pixel, that is the rover. So even if you have a very advanced satellite, you can never gonna achieve resolution what basically drone can achieve, even at height of 10 meters. So there is no competition here. So this does have high speed, and benefit of that, it can scout ahead for the rover. Now that gives basically mission planner on the rover end a lot of headroom. Basically, let's assume rover can go up to, let's say, 10 km per hour, and they're driving at 3 km per hour. And if this puppy can do high resolution pass of, like, okay, this is exactly how we want to go, let's scan this puppy 1 or 2 times to be damn sure, like, this is like every rock and pebble is properly accounted for. In those situations, they can push the rover to much higher speed, where, like, okay, rover, go as fast as you can, because again, that will save time, and because they have a lot of points. Basically, it's like waypoint A, do your mission here, waypoint B, do your mission here. So going between A and B, that takes time, and this puppy can help to shave off a lot of time, simply because it can scan the whole area in much higher resolution, feed the data to ground control, and then ground control can analyze it properly. So it does prove the potential of flight. Now what we can expect in the future? Now this is one thing you have to understand. This right now what we have is just a proof of concept. It's just like, get it done, prove that we can do it. So it's not something that you will like, you know, expand upon. You have to redesign from scratch to actually do actual mission. That is a very critical aspect. Now what it can truly do, like, okay, because inherently still a flying object. Flying object always have weight limitation. A rover can be almost 1 ton, but I do not see any future where we're gonna have a 1 ton of flying object. The atmosphere is just too thin, and again, even if you have electric power or some sort of combustion based power also, then also you have to deal with the heat issue. It's basically you are trapped inside a perfect insulation. It's not gonna be ending. Like even jet engines require cooling, so fundamentally speaking there is some inherent limitation. We can't do too much. However, the main agility of this puppy is speed. Now what can we do? That is basically main high resolution scouting mission. What does that mean? That simply means NASA in 2017 they had a concept like this, where they have this is also a drone. It also has 2 rotors, but idea with this puppy is like it's gonna take off like a drone and then shift to basically winged flight and fly along for longer. Benefit of this, if you give it same battery bank as other systems, this will travel much further, much faster and much more efficiently. So it does have higher range, and this system was complete mission. Be mindful, this was not tag along. They needed a rover because this puppy does not have solar panel. They needed a rover to actually charge this puppy and store it during dust storms and all that jazz. So the benefit of this is like if it can actually be deployed on Mars, it will scout much faster, much larger area, and because of the wing design it does have enough payload capacity to have a lot of cameras and computation algorithm. Basically it can have enough teraflops. At that point in time it can scan for what we call lava tubes much more efficiently, which we do want to study. Ideally we want to send our astronauts inside a lava tube, where it's like, okay, rocket has landed, go inside the lava tube as quickly as possible, because that time you will be completely shielded. So how can we explore lava tube? Rovers are too slow for that, and again you do not know what kind of like a geometry we're gonna find there, and you do not want your rover to be stuck there. But these things you can like even the mission they are originally drawn out, it had 2 systems, so it had double backup, and I can easily see like once they have figured things out, they can have like 10 or 20 of that, each one scouting a much larger area. At that point you will have high enough resolution mapping of that mission objective, where it's like, no, this is where we're gonna land, this is how we're gonna move the basically crew module, and we're gonna pack it inside this lava tube. So it does have some unique advantage of this. And another aspect is why I'm so excited about this is like huge support for Dragonfly mission, because till this point Dragonfly was like a okay, we might do that because on paper it does work, and Dragonfly should be a bit easier, and it has only one side effect: it's too cold. Like in Mars we overheat, in there we'll freeze. Now the temperature here is so low that most of the metal is like flat out rejected for that, because it's gonna shatter. So there is still a weight limit. However, because of much thicker atmosphere, aka thicker than Earth's atmosphere, and the fact the gravity is less, it is ideally suited for flight, like ideally suited for flight. So in those sort of scenario, basically the fact that NASA has already proven that, going to basically Congress and ask like, hey, we want to make another flying machine, that's no longer as preposterous. It's like, okay, you already did one, you already proved it, go again. And this puppy can do amazing things if it can survive the cold. So I'm kind of excited to see what NASA does, because I really like this wing design, because it does solve the rover's issues. Like, yeah, rover is gonna be the charging spot, and let's not put solar panel, because again you want to shave off every gram. Removing a giant solar panel from it will reduce your weight a lot. So this was my presentation on flight on Mars. What did it mean? What did it unlock? Hopefully you have liked this video. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike. Press it twice to show me extra disappointment. Please leave a comment, because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.